Now, so the first thing that out here we got to discuss is the objective of the internal assessment. Now, when you talk about the internal assessment, it's actually your 20% of the weightage of your IB marking. So now let's say if your internal assessment is like poor, generally it becomes very difficult to score the top grades. So what I'll be going over is in this lesson is to actually explain you entirely the criterions for the internal assessment, and how much time allocation, what is the role of the school teacher, and everything that is basically required. So first thing is that like I is actually now internally written paper by a student. It is generally internally moderated by the teacher and externally moderated by the examiners. Okay, so first thing what we got to understand is the criterions of an exploration. Now, when you look at the criterions of exploration, now generally the SLHL criterions are the same, apart from one point, which is like in the maths criteria. So we have got A, B, C, and D and E criteria. A is called as presentation. B is called as mathematical communication. C is called as personal engagement. D is something called as reflection. E is the use of mathematics. Now, what do we measure? What is the general point that we look into the presentation? Now, before I go ahead, I just say that okay. So let's say now when you talk about the internal assessment, it is a Word document or PDF format, around 20 pages. Maximum page limit is 20 pages with double spacing. That's how it is your presentation criterion. As far as the font size is concerned, there is like it should be legible. There is no restriction to that. So I will talk about in terms of presentation when I'm showing you the sample eyes in that case. So firstly, in presentation, what do we look at? In general presentation, we look at that firstly, what the student has chosen, like, and why has he chosen. So let's say presentation criteria is like why. First thing is that why. That comes as a rationale. So that comes as something called as rationale and your solid introduction. Now, introduction, if your initial introduction is bad, what happens is that your entire it is evident throughout the exploration. If you say you've chosen topic because you're interested or something like that, that makes it something which is very common. So what you have to do is when you're writing a rationale of an exploration, you got to make sure that you're giving genuine reasons you're choosing the I for, and it has got to if it has got some global significance. Next up is your coherence and your presentation, like whether you is there is tone of readability in your eye. Now, generally what happens is that lots of teachers encourage students to put the bullet forms, like okay, introduction, rationale, and so on. But what I say is that okay, with the examiner report referencing 2020, they clearly said that if you put bullet point doesn't mean that the eye is well written and well connected. Now, what indeed it does is it breaks your work into several fragments and seems like multiple pieces of work sometimes. If you don't connect, if the transition from different parts is not good. So probably once we do a sample, like going over a sample, you'll understand actually what do I mean. Next up is the so here is the tone of readability, and then second up is like your coherence. Now, coherence and the third point that they look at is concise. Now, when you talk about concise, a concise word means that what you started with, and that is linking up to your rationale. So you started with something, and then in between you just put some page fillers and something like random stuff which is not required. And the biggest problem that the students lose their marks under conciseness is because of the repetition of the calculations. Don't repeat the calculations. Don't repeat calculations at all. So that's don't repeat calculations in order to avoid conciseness. So let's say I had to find out the area under the graph for some calculation, and I have a function, let's say f of x is x squared function, and I did that. Okay, this area I showed the manual approach, a to b x squared function. I mean, it's integration concept, and I found some answer. Now you don't need to show for a next function. Like you have something like, okay, instead of x squared, this I have x squared plus 4. You have got some similar like calculation, let's say c and d, and then you're showing the entire working again. So x squared plus 4, which is like c and d, and that becomes repetitive. So that's one thing that I want my kids is not to put like, conciseness into big risk by repeating the calculations or putting unnecessary page fillers. Lots of times kids feel that, by putting some cool images will help them to understand make reader understand that. But please remember that this exploration actually is written not for the teachers, it is actually written for the peers. So number one is that your audience is not a teacher here. Your audience is a peer who can understand and comprehend your content, what you've written. That should be something that helps in criteria A. Now, if you're writing some big bang, like, uh, kind of work where it is completely out of proportion, the reader has to break their head over the content to understand, then your presentation and criteria B also sometimes is risked. So what we do is that we first choose a topic that is achievable under criteria A, which has got a relevant rationale, it has got a good introduction, and something which is achievable. Now, this also is linked up with criteria E. Now, what happens is that criteria E generally is the target for the kids in the beginning, which I don't recommend my kids to do that. So what they do is they choose a tough topic because something called as tough. What is tough for us? Now, look, when you talk about the it is something, it is a piece of work that need to show your understanding. Okay, I'm going to talk more in detail when I'm coming to this criterion. But when you're talking about something like very advanced stuff, and you know what happened is that you choose something like Laplace transformations, and then they took Fourier series, and then they take something or like higher order, second order differential equation, and these things like, so my lots of kids choose this year like chose this year ST, which is second order differential equations now, which eventually what happened is that they could show partial understanding. And if you don't show partial understanding, I mean, you show partial understanding, then you get affected in both the criterions. You communicated very poorly. Of course, penalty is only at one place. You don't get penalized twice in a criteria or twice due to a same mistake. But what's really important is that if you don't communicate your math, you don't communicate or don't explain it well, it actually affects your overall communication and the coherence, conciseness in the exploration. So that's your first criteria, decoding. And now let's go under criteria number 2. Criteria B is about the mathematical communication, which is like, it's more to do with the putting the pictures at the right place, graphs, charts. Now, let's say you're using graphs. Now, if you're putting the graphs, it must have the x-axis, y-axis. What is on x-axis, y-axis? You must put a label for it. You put like graph 1 representing this. So you should understand that part here. Now, in case if your graphs and charts are not like well placed or formatted, then things go against you. uh, Defining the variables and key terms. Now, defining variables and key terms is really important criteria. Like, for example, I took a physics related topic, which has got, let's say, a relation. Simple as W equals to mg, which is like weight equals to mass times the acceleration due to gravity. Now, for me, if I consider that, because I am knowing this stuff, so my reader who is reading the eye also knows that it is not possible. It is not something that you should assume. Don't assume. That's what I would say. Don't assume that the reader knows. Try to go back in depth, explain everything that you can, and decode like and make this difficult things easier. Make the difficult things easier. So as long as if you can do that, like where you can make the difficult things much easier, what happen is that it affects indirectly, it affects these three, that you're taking a personal engagement, also that engaging the reader also is something interesting. That okay, if you're explaining well, the reader gets connected, and you yourself feel much more connected to your exploration rather than just doing like formality of completing it. So this is something that is really important for criteria B. We'll talk about some more things from our examiner report last year's. Not talking about the personal engagement. Now, personal engagement seems like a very deceiving word, and this is a big change here. By the way, this used to be called as communication in the older criterion, and it used to be for 4 marks. Oh, this is the older one. This is the new one. I mean, I'm going to just show you the new weightage. Older one was this 4, 3, 4, 3, and 6. And the new criterion is this. This used to be mathematical presentation in older one. So don't refer the older criterions. The new criterions is presentation, mathematical communication, personal engagement, reflection, user maths. So new is 4, 4, 3 and 6. So definitely IB has definitely thought of this part where lots of kids used to lose marks. So they increased the marks. They gave a chance for the students to present something that is easier here, and you get lesser penalty chance here, but still it is a significant amount of marks that you got to be careful. Now what is personal engagement? Personal engagement is something that is automatically should come when the reader reads your work. Now there should be a connection. Now remember that there is not one occasion that decides your personal engagement. Okay, I went to do an experiment, I did an experiment, so I did something which is like brave. This is not personal engagement. Yes, it is a way to represent your personal engagement, but something relevant. And remember that personal engagement is something that actually it's not a factor. It is actually everything of your exploration. It's something that drives your exploration. Now, so when you say that something, your personal interest, that it comes up like, okay, like analysis, your mathematical calculation, your learning approach, everything should be personally driven. Take pride in your work. Take pride in your work. What are you doing? Explain it to the reader and connect to achieve your aim. And that's what is the personal engagement. And there's no limit to this. There's no limit, or there is no way to this, that okay, this is how you add up to personal engagement. It is just about giving everything that you can give to the reader, and that's what is the engagement. And we'll talk in more snapshots of these criterions, what do's and don'ts are for the good performance. Now reflection is something that, okay, obviously the word itself is reflect. Now lots of time what happens is that the students write their calculations line by line, and then there is no reflections in between the lines, and there's towards the end they'll say, okay, reflection as a subtopic or as a bullet point. Now this is not how it is. IB wants reflection right from first line until the last line. So when you say reflection, now it starts with your learning. What did you learn? Now what is something that you're really proud of in this, and what are the approaches that you took? Why did you change or modify the model? Like talk about the calculations, reflect on calculations, reflect on errors, reflect on any limitation, reflect on scope. What is how does your work find a scope in different areas? So 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 definitely out here what we understand is that reflection is something that is also one of the driving factors, and it creates the interest for the reader in criteria A as well. So remember that reflection shouldn't be just towards the end, it should be throughout the exploration. Now coming back to the use of maths criteria, use of maths criteria is definitely something that obviously drives your exploration in terms of mathematical understanding. So first thing that we look at is your level of math used. Is the level of math, is it from HL or beyond HL? Now if it is beyond HL, then it becomes a question mark that do you get above 4? So if you get above 4, then it's like a big challenge. Okay, because if you use beyond HL math, which is like something which I termed in the beginning, like Laplace Fourier, it's very difficult to get even 4. You take a level, you take a math that is required to develop your exploration, but you explain well, explain, uh, show your understanding, show your understanding, show understanding. If you don't show understanding, it doesn't support you. So showing understanding is really really important. So just being over ambitious about the topic in terms of choosing math, what I would say that choose this first, choose a rationale, and then go towards here rather than coming back from here. But there is always one trick. I might be wrong here, like directly saying okay, you go choose the topic and then apply math, but it is always that if you keep it in mind while making these decisions. So it is always mutually understandable that okay, if your math is something that is not at all available, see to it there you've got some literature before you choose the topic. So some literature at least you have, and then make a major part as this as a deciding factor, rationale as a deciding factor. Why are you choosing this topic? Let's just go over like, in depth, like quickly, the things that we just quickly talked about. So the coherence, well organized, and concise. These are the words that I discussed. So a coherent is logically developed, easy to follow, and meets the aim. So if it doesn't meet the aim of exploration, you have put some random stuff. And remember that this refers to the overall structure of exploration, including the introduction, body, conclusion, and how well different parts are linked. And for this, I recommend my kids to write in essay format. Don't use any subheadings or bullet points. It's up to sometimes the teachers force you to write it. We can't do anything in that case. But definitely when you write in essay format, let the reader understand what you've written, and that gives a sense of understanding to the writer and reader both. Now, well organized is obviously it includes the introduction, describes the aim, exploration has got a conclusion, the relevant graphs, tables, diagram at an appropriate place, and not attached as appendices. Now, lots of kids they think that you'll attach their lots of findings or tables in the appendix. Nobody, I didn't even look at the appendix this year. The students are attached. Definitely, as examiner, I mean, I look at the end parts, like whether there are some important information, but it is actually generally go on, like, it's like not significant. So anything that you're writing in your IA should be attached in the main body rather than appendix. Put the relevant diagram. Don't avoid like large tables and all the stuff, so that is something that you can really think of. Conciseness is not repeating unnecessary calculations, graph and or descriptions. Don't repeat the calculation. That's what I would say. Now coming to the technology part here, like, which is very important. The use of technology is not required as like that. Okay, but it is encouraged. And if you use technology to present your graphs, try not to write handwritten work is definitely like there is no separate uh, like criterion that your handwritten work should be penalized, but it is use of technology, Microsoft Word or anything that a good tool to write exploration is important. Criteria B, as we discussed here, is your it is about the communication, mathematical communication, which is like your key terms defined well, multiple forms of presentation, formulate, diagram, charts, graphs, and wherever necessary. Now you see that little bit of contradiction that in criteria A, these things are not counted, but criteria B, they're explicitly counted. And anything that deductive proofs or logical, like induction and all you're using, that helps you understand. I mean, there is always a reasoning involved into this communication. So that's why this criteria is more of your presentation than just like directly thinking that it is about communication. Communication is more about here, and presentation, I would say, is like you're presenting your exploration, graph charts labeled and all the stuff. Personal engagement, as I told here, there's significant personal engagement. It means that these are the 2 points. Like when you talk about significant engagement, that's point 2, and then personal this is out 3. So when you see that engagement actually is towards that, understand the writer's intention. If we understand, like it should be like at least try to put into everywhere. It's the creative approach that your exploration is written in. And finally, the reflection. If you see here, the reflection is that it is critical reflection, discussing implications, discussing results, discussing strengths and weakness in approaches, considering different perspectives. Perspectives is really important here, because sometimes you don't talk about the possibility of improvement, and then you lose the fair point of reflection. And remember that, like, it's very very limited point. If you read the criterions, you don't understand what exactly I need to write, but you got to create opportunity to write on the reflections. As far as the standard level is concerned here, like your rigor and sophistication, like challenging math, much of the challenging math is not expected here. If you look at here, just go over the criterions very carefully and annotate, make your own notes. Like see here, up till point 3, you get limited. Even you have limited understanding, you get point 3. If you use the course, the math up to the course of standard level, you still get the marks. But when you go for higher level in point 3, actually it is here some understanding. So limited word is lost and you use some understanding is demonstrated. Sometimes you might contain, if it contains partial error, like a calculation, straight away to jump to point two, however good your calculations are. And of course, they should be the major calculations in order to be given two. If you have shown multiple different maths and they're reasonable, then you can be considered for three or four, even though some part contains mistake. So that's why teachers always proofread your, like they definitely go. I expect the examiners to read the math part and understand the if there are any errors and notify to IB. So that's why it is important that don't think that your calculations are not going to be checked. Your calculations are checked line by line, and if there are any errors, you will be penalized. Now here, the biggest problem is to get 6 out of 6. Now remember that in in case of getting a 6 on 6, I hardly remember giving anybody 6 in my entire teaching career so far. So understanding these three terms, precise, sophistication, and rigor. Now when you use challenging math and use the precise, now precise is like about the word, like your work should be something that is only math that is used is to develop exploration. Unnecessary stuff you don't use, and it is correct. It is logically and easy to follow in terms of understanding, and it is thorough understanding demonstrated. So you got to show your understanding, and that's what happened if you use the bigger topics. If you use the challenging topics, sometimes it is very difficult to demonstrate the understanding. So these are all in the booklet. These you can refer into the data booklets, find out these key terms, read it again and again to understand these criterions before you start writing the exploration. So these are about the criterion breakups, and the mark width that is allotted for sevens. Generally, it is 20 points, and generally the IB award 17 to 20, it is a 7. Then 15 onwards is, let's say, 15 and 16 is actually a 6. 12 onwards is a 5, and anything below is something which is broken down to 3, 4, and 2 and 1. So this is something which is actually 5 is quite achievable in IA. So just like make sure you focus on these criterions and at least reach to this level, and then target going up in the ladder. So this is about the criteria decoding.